In this lesson, we'll be looking at how to find the equation of a circle given the center and a point on the circle. And if you are not subscribed to this channel, kindly spend a moment and subscribe so that when a new video is being published, you are going to be the first person to be notified. Now, let's get started. In example 1, it says that we should find the equation of a circle with center 5, -1, which passes through the point 1, 2. Now let's practicalize this. We have our solution here, and we are talking about the equation of a circle, which means there should be a circle. Now we have our circle nicely drawn like this. And in this circle, there is a center. Let's indicate the center of the circle with these dots. Now, the center has its coordinate as 5, -1. So that is 5, -1. Now, on this circle, there is a point on the circle. Now, let's indicate the point here, just like you can see, and represent the point with the letter P, And this point also has its coordinate as 1, 2. Basically, we can see that the distance from the center to the point P gives us the radius. Remember, from the beginning, we said that radius is the distance from the center to any point on the circumference of a circle. And we can see that the point P, which has the coordinate 1, 2, is a point on the circumference of the circle, meaning the distance from the center to the point is the radius. Now we can represent it as r. So with these parameters, then we can find the equation of the circle. Remember that the formula for finding the equation of a circle is giving us r squared, which is equal to x minus a all squared plus y minus b all squared. Now in this equation of a circle, there is r parameter and x, a parameters. Well, we don't know r, but we know a. A and b are given as the centers, whilst x and y remains constant. Now, it means that we'd have to find the value of r. From the diagram, we can see that r is basically the distance from the center to the point. It means that we can use the distance formula in getting the value of r. Now, let's try and find r. Great. And finding r is basically the distance from P to C. So here we have the distance or magnitude of PC, which is equal to r. And then that formula is giving us the square root of the coordinate x2 minus s1 squared. And then the next one here is y2 minus y1 squared. And this becomes the formula you find the distance from the center to the point. And that becomes r, which is equal to the square root of, now what is x2? You can get x2 by simply taking into consideration the center and the point. Here becomes x1, and we know here to be y1. Here becomes x2, and we know here to be y2. Now, x2 we know to be 1, and we know what x1 to be 5. So we have our minus 5 here squared. Plus y2 we know to be 2, and y1 becomes -1. So but there is a existing negative here, that becomes negative of 1 all squared. At this point in getting r, then we should have r to be equal to the square root of 1 minus 5 you know to be 4, and that is -4 to be precise, and -4 squared gives us 16 plus, so 2 minus -1 gives us +3. And we know +3 to be the same thing as 9. That is +3 squared giving us 9. When we sum that of 16 and 9, we are getting 25. So at the end, the square root of 25 gives us 5. So our r here is 5 units. We are bringing the units here because it's a distance and it's measured. Now having r, we can easily get the equation of the circle. Remember that we said the equation of the circle is giving us r squared, which is equal to x minus a all squared plus y minus b all squared. Now we know r squared here to be 5, so that becomes 5 squared, which is equal to x minus a. But we know a is the center, and a from the center we have 5 here. So that becomes 5 squared plus y minus, and we know b to be the center, but the center is minus 1. So that becomes minus 1 squared. Here we have 5 squared, and 5 squared is the same thing as 25, which is equal to x minus 5 all squared plus y plus 1 all squared. Now at this point, this becomes the standard form, and equations like this, we have to reduce it to the general form. So by expanding, then we have 25 to be the same thing as, when we square x minus 5, then we should have x squared minus 10x plus of 25. That is for x minus 5 all squared. And when we square y plus 1 squared, then we should have y squared. Then let's continue here, plus 2y plus 1. So at this point, we can continue by writing or by grouping like terms. So here becomes x squared plus y squared minus 10x plus 2y, and we can transpose 25 to the other hand side. So that becomes 25 minus 25, and we have here as minus 1 is equal to 0. So at the end, the equation of a circle now becomes, yes, remember that this is plus 1, not negative 1, so it should be plus. And here we can see that the positive 25 we take away negative 25, and at the end the equation of a circle now becomes x squared plus y squared minus 10x plus 2y plus 1, which is equal to 0. And this becomes the equation of the circle. Now, having known this, let's move to the next example of today's video. For example 2, it says that find the equation of a circle whose center is at the point 2, 1 and passes through 4, negative 3. So here, we first have to diagrammatize this. And when we have, or when we draw a circle, we can see something of this form. And this circle has its center, and the center also has its coordinates. And the coordinates of the center is 2, 1. And there is also a point on the circle. Now let's name this point P with the coordinate 4, negative 3. We know that the distance from the center to the point gives us the radius. And here we have here as r. And to find that distance, or to find the radius r, is basically the distance of the line PC, which is equal to r. And that formula is giving us the difference of the coordinates of x2 and x1 squared plus that of y2 minus y1 squared. And here we can see that r is equal to the square root of, now x, so here we have here as x1, you can have here as, sorry, so here is x1, then here should be x1, then we should have y1 here. Here we have x2, then we should have y2 here. Now x2 we know to be the same thing as 4 minus x1 we know to be as 2 all squared, and then plus y2 we know to be the same as negative 3 minus y1 as 1, that is squared, and continuing give us r squared, so that is r, sorry, which is equal to the square root of, 4 minus 2 gives us 2, and 2 squared gives us 4, plus negative 3 negative 1 gives us negative 4, and negative 4 squared gives us 16. So we have here 16. Now we can see that our r is equal to square root of 20. So we can term this as square root of 20 units. The next step is to find the equation of a circle. And that formula we know is giving us r squared to be equal to x minus a all squared plus y minus b all squared. And once you know the value of r, we just do substitution. So here we have square root of 20 all squared, which is equal to x minus a, and a is the center, and that coordinate is 2 squared, and you have here as y minus b, you know, is same as the center, that is 1, so we have squared here. Now consider that the square takes away the square root, we are left with 20, which is equal to x minus 2 all squared plus y minus 1 all squared. Now we just have to expand this. Expanding gives us 20 to be equal to n squared minus 4x plus 4. And then we have here as y squared minus 2y. Good. So it should be 2y. And then plus of 1. Further, we can break it down or group items, and our final solution is now by x squared plus y squared, and we have minus 4x followed by minus 2y, and when we transpose 20 to the right hand side, we get negative 20, and we add negative 20 to 4 and that of 1, and at the end we should get that of minus 15, which is equal to 0. So at the end, the equation of the circle with the center 2, 1 and passes through the point 4, negative 3 is giving us x squared plus y squared minus 4x minus 2y minus 15 is equal to 0. And this becomes the equation. Now we are moving to the last set of examples for today's video, and you stay tuned as we move along. So this becomes example 3. At this point, you can pause the video and try your hands on this question. You continue, and it says that write the center to radius equation of a circle with center at 20, 10 and passes through the points 9, negative 8. So just like we have been doing from the previous examples, then it would be very nice if you can draw the circle we are talking about, and you can also indicate the center. Just like we can see here as 20, 10, and the point we are talking about, that is 9, negative 8. And the distance between the center and the point, you know, to be r. So finding r basically is equal to the square root of x2 minus x1 all squared, and then there is plus of y2 minus y1 all squared. Now by direct substitution, since you know the value of x2, x1, y2 and y1, then our r is now is equal to the square root of, so our x2 we know to be the same thing as 9 minus x1, that is 20, so we square them, and you also consider y2, that is minus 8, and our y1 becomes that of minus 10. Here we square, so our r now is equal to, when simplified, we have the square root of minus 11 squared and that of minus 18 squared. Now when we break this down, our final answer becomes the square root of 445 units. And this becomes the value of r. Now we also know that in finding the equation of the circle is giving us r squared, which is equal to x minus a all squared plus y minus b all squared. Here we know r to be equal to square root of 445. So we take the square root of 445, and the next thing is to square, which is equal to x minus a. Now our a value here is 20, so we square it, and our y is maintained. Our b value here we know to be 10, so we square. To continuing, this gives us 445, which is equal to x minus 20 all squared plus y minus 10 all squared. Now, since the question is talking about center to radius equation, then the focus should be on the center and radius. So basically, the equation of the circle that is considering the center to radius is what we can see here, that is 445, which is equal to x minus 20 squared plus y minus 20 squared. So we end to this video here. So thanks for watching. Kindly like, comment, subscribe, and share. This is BakoMaths, thinking beyond infinity.